In this video, we are going to start with the unit number 6, that is pointers and memory. In this first video, we will see the topic of pointers. So as per the syllabus, the topics that we will cover are pointers, what is double pointer, what is referencing and dereferencing, what is call by value and call by reference, what are dangling pointers, void pointers, null and wild pointers, and then the remaining concepts in the upcoming videos. So to begin with, as I've already mentioned earlier, that data is stored in memory in your computer so that we can access the data stored in the particular memory location. Each memory location is of 8 bits, and 8 bits is equal to 1 byte. So here the address of this memory location is 1000, and the size of this memory location is 8 bits. Each memory location is of 8 bits. Now the next address can be 1001, 1002, and so on. So each section holds 8 bits. So here, since we are starting from 1000 and going up to 1019, total how many bytes of memory we have? We have 20 bytes. Now suppose we have an integer with the name I. Integer occupies 4 bytes in memory. Since it occupies 4 bytes in memory, we need to access 2 memory locations because each memory location is of 8 bits. This is 8 bits, means one byte. Here let us consider, since integer, the size it occupies depending upon your compiler and system, let us first consider that it occupies 2 bytes in memory. Suppose integer occupies 2 bytes in memory, then this is 1 byte and this is also 1 byte. So if we consider 2 memory blocks or 2 memory locations, in these 2 blocks, a single integer value can be stored. So when memory is allocated to the variable I, which is of integer data type, 2 blocks of memory, each of 8 bits, that is total 2 bytes, is allocated. So suppose integer I variable is allocated memory by using these 2 blocks. So the address of the first block is 1002 and the address of second block is 1003. So the starting byte is at 1002. This is the first byte. And this is the second byte. Since integer occupies 4 bytes. Now a pointer is a variable which can store the address of another variable to which it points. I repeat, a pointer is a variable which can store the address of a particular variable to which it points. Means, since each variable is stored in memory location, each memory location has a particular address so that you can access that particular memory location. And the address of that memory location can be stored in a variable, and such a variable is called as a pointer variable. So pointer variables are the variables which will store address and not data. So the value of a pointer is always an address. And using the pointer, we can access a particular address. And at that address, we find a memory location. And in that memory location, some data is stored. And that data can be of some variable. So suppose P is a pointer variable or a pointer then it points to the address of the memory location at which the integer is stored. Since integer will occupy 2 blocks of memory, that is each of 8 bits, that is each of 1 byte, that is 2 bytes. So the pointer will always point to the first byte. Means first byte is at address 1002. Since it is 2 bytes, it will point to the first byte, and using this we can access the value which is stored in I. This whole block will be considered together, but pointer points to the first block. And using this pointer, we can access the value of I variable. Suppose I was a character, then how many blocks it would occupy? Can you tell me? Since character occupies 1 byte in memory, it will occupy or be allocated 1 byte of memory. Since 1 byte of memory means 8 bits, and 8 bits means a single block. Suppose this block. So a single block is there for a character variable because it is of 8 bits or 1 byte. So pointer will directly point to this address. A single block. For integer, 2 blocks. For character, 1 block. Suppose integer occupied 4 bytes, then 4 blocks would be allocated. So pointer is a special variable that is capable of storing some address. And at that address, some data is stored which is of some variable. So a pointer can point to the memory location. Here, suppose I is a variable and it is allocated memory at the address 1002. Then what will be the value of P variable? That is, what will be the value of pointer variable? The value of the pointer variable will be 1002. Okay. Variable I is stored at the location 1002, having address 1002, and the pointer can store that address. So value of I can be some integer, but the value of the pointer is the address of that location. I hope you understood. So this is another example. Consider this is a variable var. The value of var variable is 10. And this variable or this data is stored at the address, this one. Now address in computer memory is usually in hexadecimal format. Means the base of the hexadecimal numbers are from, the base is 16. So numbers that are acceptable are from 0 to 15. So this is an hexadecimal address. This is the address of the variable which stores the value 10. And we can access this variable using the pointer which points to this variable. So the pointer name is PTR. This pointer variable points to the variable 10. And it will store what now? Will it store 10 or will it store the address? It will store the address. It stores the address, and this address is of the variable. And the pointer variable itself needs to be stored in memory. So it will also be stored at some address. So this, what I've written below, is the address of the pointer variable. I repeat, variable var stores the value 10 and it is allocated memory at the address, this one. And this address can be stored in the pointer variable, and the pointer itself is stored at some address. I hope you have understood this. So the syntax of declaring a pointer: the data type, you have to give an asterisk or a star and then the pointer name. So data type of the pointer, now pointer store address. So address doesn't constitute any data type. So the data type of the value to which it points is the data type of the pointer. Suppose we have a variable I and ptr is a pointer which points to I. Since I is an integer, it is the data type of I, then the data type of ptr is also integer. So this is the syntax: data type, asterisk, and then the pointer variable name. Here the data type refers to the type of the value that the pointer points to. For example, this is an example of declaring a pointer. So by this we come to know that This PTR is a pointer which will point to an integer. It cannot point to other data type. It cannot point to variables of other data type. So data type to which it will point, asterisk, and the name of the pointer variable. You can give any name, but usually by convention and standard, you must give the names as PTR or PTR1, or you can write P or P2 or whichever. Usually in P we write it, but it can be anything. This is an pointer to an integer. Second example is pointer to a character. Why? Because data type written here is char. Next is a pointer to a float. Now the need of address of operator. Now we have studied different types of operators in which I had told you about address of operator, and this is usually used in pointers and to access address of a particular entity. Address of operator is written with ampersand symbol. Okay, this is not bitwise AND, this is not logical AND, this is address of operator. The syntax to use address of operator is what? You must write ampersand and then the variable name. Okay, ampersand and then the variable name. This is the syntax to use address of operator. Now the need of this is there's no use of simply declaring a pointer. We need to initialize a pointer and data of the variable using the pointer. Pointer points to some variable and we should be able to access that variable using the pointer which points to the variable. So it is important to initialize the pointer. One way of initializing the pointer is by assigning address of some variable to that pointer. We must store an address in a pointer. If we store an address in a pointer, then it is said that the pointer is initialized to that address. For example, this is a simple variable which is declared and initialized in the same line, int x equal to 5. So the value that is stored in variable x is what? 5. And in memory, how we can represent? Draw a simple block. It is addressed or accessed by the variable name x, and it is stored at the address 1000. Now we will declare a pointer. This is called declaration. Pointer declaration. Int. Why int? Because it should point to an integer. Because x is an integer, ptr will point to x, so its data type is int, asterisk, and ptr. Ptr is the name of the pointer variable. So even ptr should be stored at some address in memory. Everything that you write in your program or everything that the computer needs to access should be stored somewhere in memory. So x is stored at the address 1000 and ptr at 2000. Now this is the way of initializing a pointer. This is pointer initialization and this is pointer declaration. So you must write the name of the pointer without asterisk. Writing asterisk here is not valid. Name of the pointer variable and then assignment operator and then ampersand and then the name of the variable to which the pointer should point. I repeat. The name of the pointer variable, assignment operator, then ampersand operator, or you can call it address of operator, and then the name of the variable to which the pointer should point. And this way of writing any line of code is known as referencing. Whenever you write ampersand any variable name, and if you access this address, it is called as referencing. So what this line of code does, if you simply write ampersand variable name, it returns the address of the variable. Wherever the variable is stored in some memory location, it has an address, and that address can be accessed by writing ampersand x. So suppose in a printf statement, if you want to print the address of any particular variable, you must write ampersand variable name. This will print the address of that particular variable. So this address we want to store in the pointer variable. So you have to use assignment operator, and this address which you have accessed here, you have to store it or keep it in pointer variable. I hope you understood. This is called address of operator. And now the address of X is this one, which is stored in PTR. So the value of PTR is what? Can you tell me? The value of PTR is nothing but the address of X. The address of X is what according to this example? This is just an assumption that it is 1000, not necessary it is always 1000. The address of X is 1000. So value of PTR should be what? 1000. Okay. And PTR points to X. Value of PTR is the address of X. X is stored at 1000, so the value of PTR is 1000, and PTR itself is stored at 2000. So as I mentioned during variable declaration and initialization, you can declare a particular variable saying int a, and then you can initialize it by saying a is equal to 5. Okay, this two steps can be performed in a single line of code, like int a is equal to 5. Similarly, this is declaration and this is initialization can be combined by writing int asterisk PTR is equal to ampersand of X. Okay, this part is declaration and this part is initialization. This is declaration, this is initialization. The same effect you will get. These two statements can be written like this, and these three statements can also be combined. How? Suppose we want to declare and initialize more than one variable of the same type. Then we write int a is equal to 5, use comma as a separator, b is equal to 9. This way we can initialize and declare variables of the same type in a single line. Similarly, since the data type of the pointer as well as the integer is same, so this can be combined on a single line. Means you can write int variable name is equal to suppose 5, and then use comma operator, and then you can initialize your pointer by writing star PTR is equal to ampersand X or ampersand V in this case. So integer is the data type of V as well as PTR. I hope you understood this. So this is known as address of operator. This is called address of operator. Now, this is used to access the address of a particular entity. Next, we will study value of operator, or it is also called as indirection operator or dereferencing operation. Whenever we use ampersand, it is called referencing. Whenever we use value of operator, it is called dereferencing. So, referencing or value of operator is nothing but your asterisk. Okay, this is your value of operator. This is not multiplication in this case. In case of pointers, asterisk is what? It is value of operator. It is used to access the value stored at a location pointed to by the pointer. Means whatever address the pointer has, whatever address is stored in the pointer is what? The address at which the variable is located. So if the value of PTR is 1000, means PTR points to a memory location at the address 1000. Okay, and at that address 1000 to which is the value of PTR, at that address 1000 some data is stored, and that data we want to access. Okay, so that can be accessed using value of operator. I repeat, the value of PTR is an address, and at that address some data is stored. So using PTR we want to access that data which is stored at the address, and that address is the value of the pointer variable. So see by example, it will become clear to you. Suppose a simple variable integer x equal to 5. So it is represented in memory. Then declare a pointer variable of integer type. It also has some memory space allocated to it. Then ptr is equal to ampersand x. So ptr will point to x. So what we know till now, that the address of x is the value of ptr, isn't it? Now, if we want to access the value 5 using ptr, see, we can access 5 using the variable x, right? We can simply print x, we can print 5. But we want to access this data of x using the pointer. Now, how come this is possible? This is only possible if ptr, or if the pointer, points to x. If ptr doesn't point to x, then we cannot access x using ptr. Since ptr points to x, we can access x using ptr. So the way we do it is using asterisk ptr. The syntax of value of operator or reference or dereferencing is writing asterisk and then the name of pointer variable. Okay. Here, whatever you write after asterisk should be a pointer variable. It cannot be a simple variable. So whenever we execute this printf statement, what will get replaced here in place of %d? In place of %d, what will come? Asterisk ptr. And what is asterisk ptr? It is the value 5. Okay, because ptr points to where? To x. I hope you have understood this. You can rewind the video if you haven't. Now, this as a value of operator says that we must go to the address of the object and take whatever is stored in the object, isn't it? We must go to the address. Okay, how can we go to the address? We can go to that address because that address is the value of the ptr. The address is the value of ptr, and we can go to that address, and whatever is stored at that address we can access using value of operator. So as I said, output is 5. Now we can also change the value of the variable or of the object to which the pointer points. Means what? Till now what we were doing, let me show you here. Till now we were doing this. We were saying int x is equal to 12. Then we were doing int star ptr is equal to ampersand of x. And then we can access the value x using ptr. Okay. And one more thing that you can note is either you can write int star space ptr, or you can write int space star space ptr, or you can write int space star ptr. Okay. There's no different effect if you give space like this. Okay. Now we can access the value 12 using ptr. How? By we can print using %d. What we can print? Star ptr. What will get displayed here? The value 12. Now, if we want to change the value of x using ptr, till now we were only accessing x using ptr, but now we can also change the value of x using ptr. How can we do that? We have to simply write in our code star ptr is equal to updated value. Suppose you want to change the value of x to 13, then we must write star ptr is equal to 13. Okay, why this is possible and why this is valid? Because ptr stores the address of some location. So at that address we can write anything or we can read from that address. Okay, we can read or write at that address. Means we can read the value stored at that address, or we can write some value at that address. And since that address holds some data, and since a variable is associated with that address, so if we make any change in the value at that address, then the value stored in the variable of the corresponding address will also get changed. I repeat, at the address that is 1000. PTR stores the address 1000. So at the address 1000, you can write any value. And since at the address 1000, the variable x is stored, so the value of x will also get changed. Why? Because both the ways that in which we are using, both the ways to access the data, what are the two ways? Using the variable x and using the PTR variable. Using either x or PTR, we can access the data 5. But the data 5 is stored only once in one memory location. Okay. So if we update the value using PTR, the value 5 will disappear and some new value will come. If we update the value using X also, some different value will come. Means what? There are two ways of doing this. Either you have int, so you have X variable and you have PTR which points to X. So either you can change the value of X by saying X equal to 13, okay, or you can write star PTR is equal to 13. Both these ways will change the value of X and the value in the memory location as well. I hope you understood this. This is value of operation. See your example, X is equal to 10 and star PTR is equal to ampersand X. So PTR points to which variable? X. Okay, I've represented it in memory. Now if I write asterisk PTR equal to 4, what should happen? Can you guess? Yes, you can store the value 4 now and the value 10 is vanished, disappears. The value is 4 now in the memory location. Okay. And now when you use asterisk PTR, what will get executed by this printf statement? Can you tell me? The value of X, that is the value 4, isn't it? Output is 4. I hope you agree with me. Now let us see it in some program. All this theory we have seen, let us see some programs now. As usual, I've included the header file stdio.h. Now this is int main function, so I have to return 0. And here I have a simple variable x, and then using this address of operator or ampersand, what will get printed? Can you tell me? I hope you guessed this right. Using this operation, you are referencing. Means you can access the address of the variable. What is the address of x? It is some address in the memory, and that particular address will get displayed, isn't it? So let us test this code snippet. A code snippet is nothing but a small piece of code. So when I run this program, this is the address of x. As I told you, address is hexadecimal. So you have these letters also. F indicates what in hexadecimal? It indicates 15. E indicates 14. And C indicates 12, isn't it? So you can access the address of any variable or any entity using this address of operator. Now let's see the next small piece of code. See here, now in this, what you can do, int main function, int x equal to 10, and then declaring pointer and initializing pointer. I hope you remember this is declaration and this is nothing but initialization, isn't it? So this is the way you can initialize the pointer. So now what I'm doing, let us see the next program now. This was just to demonstrate declaration and initialization. It will not give any output as such because we are not printing anything. Now, in this part of the program, what we are doing, var is a variable which holds 10. PTR is initialized to var in a single statement, declaration initialization together. Then I'm saying value of var is equal to asterisk PTR. So what will be printed here? Can you guess? Value of var is what? 10. And this is value of operation or dereferencing. So the value 10 will get displayed. Instead of writing star PTR, what else can you think of? You can simply write var also here, isn't it? If you write var, the value of the variable will get replaced with %d. So using pointer, this is the way. Now, as I told you, even pointers are stored in memory. Okay, so they also have certain address. Now, another thing that you can note that the value of PTR is what? Can you tell me? Value of PTR is nothing but address of X, address of var variable, in this case var variable. So address of var variable is the value of PTR. So what will be the output here? The address of var variable, isn't it? The address of var variable is the value of PTR. And another important thing, whenever you want to display address, which format specifier you will use? You cannot use %d. It may give you error or some undefined behavior or undefined value. You must use %p. P for pointer, so you must use %p. You can display any address at the output using %p. Now, as I already showed you, you can also change the value of var. You can change the value of var to 20. How? Either write var equal to 20 or asterisk PTR equal to 20. It will update the value in the memory location. And since var and PTR point to the same thing, it will give you the same updated value. So after doing asterisk PTR equal to 20, asterisk PTR is, okay, let me execute this much. See here, line by line, we will go through the output. See, first is value of var is 10. This is coming from where? From this one. So asterisk PTR, as we discussed, value output is 10. Now address of var. How can we access address of var? Using PTR. Only write PTR because value of PTR is address of var. Okay. Now, instead of writing PTR, what else can you write to get the same output? Can you guess? See, this is the address of var, okay? Ending with FE98. Now, address of var can also be accessed by writing what? Ampersand var, isn't it? And the same ampersand var we have written here, and that is stored in star PTR. So ampersand var, when I execute, see here, I'm getting the same thing, FE98 address. I hope you have understood this. So using pointer, what will be the accessing address? PTR. Then third line of code is what? After doing star PTR equal to 20, star PTR is 20. Okay. Star PTR is 20. So 20 is the value. Now, what do you think? The value of var is also 20 or is it the old value 10? Can you tell me quickly? The value of var is also updated. So without doing var equal to 20, I repeat, without doing var equal to 20, I have updated the value of var and now I'm printing the value of var. Let us see if 20 is displayed or no at the third line of output. So as you can see, 20 is displayed here. And what is that 20 from where it is coming? It is coming from var. Because since I've done star PTR equal to 20, the value of var has also got updated, isn't it? Another concept that you can see is pointer arithmetic. In pointer arithmetic, you will be able to use some arithmetic operation, either addition, subtraction, multiplication, or even division, to change the value that you want to access. See here. So here, what I'm using a simple variable char, which stores which character? Capital A. So can you tell me what is the ASCII value of capital A? It is 65. Now, whenever you see any data type star, okay, one more thing I want to tell you. Whenever you see data type asterisk, means whatever you write after this, PTR, whatever this much if you see, it means that whatever you write after this is a pointer to this data type. Okay, whatever you write after char star is a pointer to char, isn't it? So I'm initializing pointer to point to x. So pointer will point to the variable x. And now I'm updating the value of variable x. How? By doing star ptr equal to b. So now the value of x should be what? Character b. So here x is equal to %c, and using %c I am displaying the value of the variable x, which is nothing but b now. It is updated. Okay, let me execute this much and show you. See, x is equal to b. Initially x was equal to a, it is updated to b. Now, suppose I write plus plus star ptr and I'm displaying using %c. So what do you think? What will be the output? I hope you get it right. Since we are doing plus plus value, okay, whenever we write star ptr means it is some value. Since ptr ka data type is char, it is some character value. Okay, and to that value I am doing plus plus. So currently what is the value? B. So ASCII value of B is what? 66. ASCII of B is 66. So when I do plus plus 66, what will happen? It will become 67 by pre-increment. So 67 I am displaying using %c. So the character equivalent of 67 will get displayed. So first let me use %d and show you what is the output. See here, using %d I'm getting 67. 67 is ASCII value of character c. So when I use %c here to display, I should get c, as you can see. Okay, so this was pointer arithmetic, where you can update the value of the variable using pointer and some arithmetic operation. You can do minus minus also here. So what will happen? Currently it is B, it will become A, as you can see here. Similarly, what else you can do is, you can write star ptr is equal to star ptr plus 10. Okay, so what is star ptr now? It refers to variable x. In that, I have stored b. So the ASCII value of b plus 10, that is 66 plus 10 is 76. So the character equivalent of the ASCII value 76 will be displayed here if I use star ptr. I need to give semicolon. So see, corresponding to ASCII value 76, I am getting the character L. Okay, it is correct. So these are some arithmetic operations that you can perform. Plus plus, minus minus. You can even write star ptr is equal to star ptr into 10. Okay, corresponding thing will get displayed. I hope you understood pointer arithmetic as well. Now some tips or some points that you need to ensure. You should never apply indirection operator. Indirection operator is nothing but your asterisk. You must never apply this to uninitialized pointer. Means you have only declared your pointer, as in this case, but you have not initialized it, right? You have not written equal to ampersand variable name. You have not written this. You have only declared it. So in this case, if you try to print the value using this statement, what you're doing, you're printing value. You're writing asterisk ptr, but it is not initialized only anywhere. So how can you access any value, right? It does not refer or indicate any memory location. So how can you access the value at that location? So this will give you undefined error, or it may not run properly. Let us see what happens. See here, hash include stdio.h, then void main, and here I'm declaring, suppose let me use float for a change, float asterisk ptr, and then in printf I'm using %f, print a floating point value by using value of or indirection operator. Let me save this as caution, as a C file. And when I execute this, see, it's not giving any output, either error or no output. I hope you understood this and the reason behind it. See, undefined behavior or no output. Now, another thing, assigning value to uninitialized pointer is dangerous. Means what? Here I'm declaring the pointer and then I'm writing asterisk PTR is equal to 1. But PTR, see, you can point a pointer to a variable only or a function also, which we'll see in later stages. You can point a pointer to a variable or a function. But here, what does PTR point to? See, the value 1 is just a value. It is not like stored in memory. What is stored in memory? Only the variable, and the value of the variable gets stored in the memory. A direct value cannot get stored in the memory. Directly, the integer value 1 is not stored in memory. If 1 is the value of some variable, then that variable is stored in memory. So you cannot initialize a pointer to, like you cannot write asterisk p of integer data type equal to 1. Okay, this is not valid. This is initialization. This is not updating any value. This is initialization of pointer, which should be done only and only to a variable or function. You cannot even write ampersand 1. Okay, there's no address of 1 over here. I hope you understood that only variables or functions must be the initialization to a pointer. So here star pointer equal to 1 is to tell us that update the value. So what the user is trying to do is, you have int asterisk PTR, and here if you write equal to, that is assignment operator, equal to ampersand of a, suppose. So the pointer PTR points to the variable a. And now if you want to store some value in a, or you want to store some value at the address of a, then you can write PTR is equal to 10. So the value of variable a will become 10. When you print a, it will give 10. If you print asterisk PTR, it will give you 10. But here what is missing is the initialization. This is missing in this case. So the initialization is missing. PTR does not point to any location. And there, if you are writing star PTR equal to 1, it is not correct what you're doing. So output is what? Segmentation fault. Usually segmentation fault is an error, which is the output in the cases where you try to access the invalid memory or invalid memory locations. Usually segmentation fault is caused by the programs trying to read or write to illegal or invalid memory locations. I hope you understood these points of caution, and I hope the idea of pointers is clear by now. So this is just the basics. Pointers are used in different domains, and the main advantage is what? You can directly access the memory location or the address of the variable or function, isn't it? Now, what is double pointer or pointer to pointer? Till now, whatever we have seen is a single pointer, but now we can have double pointers also. Double pointer means there are two pointers. One pointer points to a variable and the second pointer points to the first pointer. Okay. A pointer points to a location in memory and it can be used to store the address of the variables, because the value of a pointer is nothing but an address of the variable to which it points. So when we define pointer to pointer, the first pointer is used to store the address of the variable and the second pointer is used to store the address of the first pointer. So here one pointer points to another pointer. It is called as pointer to pointer. When one pointer stores the address of another pointer, it is called pointer to pointer. Since pointer can store only address, so the second pointer will store which address? it will store the address of the first pointer. Okay, with program examples, this concept will get clear if you have not understood. So how to declare a double pointer or a pointer to pointer in C language? We have to place an additional asterisk. Okay, our normal declaration is what? Int asterisk p. This is a single pointer. But if we want to use double pointer in our program, then we must write int asterisk asterisk, say p1. So p1 is a double pointer, and it will store the address of which one? It will store the address of p. So we can write here, see here, double pointer. Consider the variable var, and the value of var is 10. Var is at the address 2008. This is the address of var. ptr1 points to var. So what is the value of ptr? 2008. And ptr1 is stored at which address? 4020. And ptr2 points to ptr1. So what is the value of ptr2? Address of ptr1. What is the address of ptr1? 4020 is the value of ptr2. And ptr2 is also stored at some location which has the address 3096. So we can have another third pointer. That means 3 asterisks we have to give before the declaration. So we must write in that case int asterisk 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 ptr3 is equal to ampersand ptr2. Since ptr should point to ptr2, we are using this at the right hand side, and 3 asterisk means this is triple pointer. Okay. So how it works? Initially, var variable has the value 10. This is its representation in memory. It is at the address 2008. Now I'm saying int star ptr is equal to ampersand var. So ptr points to var, and then I'm updating the value of var to 20 using the pointer which is pointing to it. When I write asterisk 20, what will be the value of var? It will be 20. 10 will disappear and you'll get 20. Okay, 10 is cancelled. You get, now the value of var is 20. So when you print asterisk ptr or when you print var, what value you'll get? 20. Now next is a double pointer. So int asterisk asterisk ptr is equal to ampersand ptr. You can write here ptr1 and ptr1 points to ptr. So I'm updating the value of which one now? I'm updating the value of var by using double pointer. Whenever you write asterisk asterisk ptr, you will be able to access the location at which var is stored. Var is stored at 2008. You will be able to access this location by giving 2 times asterisk and ptr. And then if this I assign it using 30, then what will be the value of var? The value of var will be the value 30. So using asterisk asterisk ptr, I can access the value of var and update it. So 20 also disappears and 30 is stored in var. So now when I display star ptr, what will be the value? Will it be 20 or 30? It will be 30, because all the 3 ways, they refer to the same memory location. So now whatever is in the memory location is the latest updated value 30. So if I try to print asterisk ptr, it will give me 30. If I print asterisk asterisk ptr, also 30. And if I print var also, it will give me the value 30. I hope you understood this. And another thing that I want to show you is, as I've told, that ptr itself is stored at some address. So here if I say float x equal to 1.23, and then I initialize the ptr to x ka address, and here I can access the value of x by this syntax, this printf statement. But what if I want to access address of the pointer? Okay, I want to access the address of the pointer, so I have to use format specifier %p. And if I print ptr, then which value will get displayed? Will it be address of ptr or will it be address of x? The correct answer is address of x. Because ptr points to x, its value is the address of x. But if I want to print the address of ptr, I don't want to print the value of ptr, that is address of x. I want to print the address of ptr. I'll use %p and then ampersand ptr. Using ampersand, I can access address of any entity. So using this, I can access the address of ptr. This is address of ptr. If I want to access x, simply I can do it this way also. So this will give me value of x. If I want to access the value of x using ptr, then what I'll do? Asterisk ptr. So this will also give me value of x. If I want to access address of x, what can I print? Simply ptr, or which is another way? Can you tell me quickly? Yes, you can use ampersand x. This will also give you what? Address of x. Now, if I have another pointer, ptr1, and it is a double pointer, so it should be initialized to ptr ideally. And now if I want to access the value of x variable, then what will I have to print? Asterisk asterisk ptr1. This will give me value of x. If I want to access the address of ptr1, okay, I want to access the address of ptr1, then what I'll write? Ampersand ptr1. If I want to access the value of ptr, what can I print? I want to access the value of ptr. What is the value of ptr? It is an address. Which address? Address of x. So which format specifier? %d or %p? %p. And then I want to access the value of ptr using double pointer. So I will have to write single time asterisk ptr 1. Okay. If I write twice asterisk, I'm getting x. If I write once asterisk, the immediate ptr I'll get. Value of ptr. What is value of ptr? Address of x. Let us execute till here and check. Let me give a \n everywhere. So as you can see, here also \n. See, this is what? Address of x. Then second address is address of ptr. This one. What is the value of x? 1.23. With, just a minute, I need to use which format specifier here? %f, not %p. So it will give you any garbage value or some error. So value of x is using %f is what? This third line, 1.23 with 6-digit precision. I hope you remember what is precision. Then if I write star ptr, it will give me again value of x. If I write ampersand x means address of x, and that is the same value of ptr. So first line and fifth line should be the same. See here, first line is fe96 and fifth line is also fe96. So ampersand x or ptr gives the address of x. This is proved by this program. I'm using double pointer now and I'm initializing it to ptr. And the value of x I'm accessing by double pointer. So that is 1.23. Then ampersand ptr, what will this give me? It will give me address of ptr1. So address of ptr1 is this one. And if I want to access the value of ptr using ptr1, then single time once only asterisk and this one. So what is the value of ptr? Value of ptr is address of x. That is first line and last line are same, isn't it? If I write ptr, it is value of ptr. What is the value of ptr? It is the address of x. What is the value of star ptr1? It is the value of ptr. What is the value of ptr? Address of x. Okay, you can rewind the video to understand this concept again if you haven't understood. Now, this was double pointer. Now, what is call by reference and call by value? See here, just a quick recall or revision. When we studied functions in our recorded videos, I had mentioned about actual and formal parameters. So whenever you give the function call, see this statement, these are what? Are they actual or formal? They are the actual values which we are passing. So they are the actual parameters. And where do they go? To the function header of the function definition. And in the function header, the value of m is stored in A and value of n is stored in B. So these are your formal arguments and you can manipulate on these values. Okay. Now call by value. In call by value, the values of the parameters will be copied to the formal parameters. So the value of m is copied to A and n is copied to B, as I mentioned. And A and B over here in the function, and m and n, which is in the, suppose we are calling the function in main. If we are calling the function in main, then m and n are local to which one? Main. M and n cannot be accessed from add function and A and B cannot be accessed from main, isn't it? M and n are local to main, A and B are local to add function. So from where to where copying is taking place? From actual to formal. And there are different memory locations, different variables. So when I say int x equal to 10, y equal to 20, and if I'm calling function fun by passing parameters x and y, parameterized function call by passing two parameters. So locations are there for x and y in memory. And the definition part is this one. So value of this x and this y is different from this x and this y. Though the name of variable is same, their scope or lifetime is different. I've already told you what is scope. It is the region from which you can access the variable without error. And here in the function, I am updating x as 20 and y as 10. So the x and y of fun function is 20 and 10 respectively. But the x and y of main function, if this is in main, then in main function, x and y are 10 and 20. Okay. So x and y locations are created for fun function also. The x and y related to fun function is this and this. So they have the values what? 20 and 10. Okay. These x and y are of this one. This x and y are of this one. So now when I print here x and y, it is this x and y which will get printed. If I use printf over here to print x and y, what will be the values? 20 and 10. But here printf will catch these values, 10 and 20. But that was all that till now what we have seen in functions is call by value. But from now on, we can also see call by reference, since we have studied address of operator and value of operator, that is referencing and dereferencing. So here, instead of passing the values or the parameters, we will not pass them, we will pass the address of the parameter. I repeat, instead of passing values, we will pass the address of those variables or parameters. So here, what will be the change? Instead of fun x comma y, you will write fun within parenthesis ampersand variable name, that is parameter, and ampersand parameter. So what we are passing here, we are not passing 10 and 20. We are passing the address of x and address of y. So in memory, how it is, x has some location, y has some location. At the address 1000 and 2000 respectively, they both hold values 10 and 20. And what we are passing, we are not passing 10 and 20. We are passing address of x and y. What we are passing then? We are passing 1000 and 2000. So the value 1000 is the address of x and 2000 is that of y. In the definition part, since you are passing address here, address can be the value of a pointer, isn't it? Address is the value of a pointer, and a pointer can be initialized to an address. So here in the argument list of function header, you must use pointers instead of the simple parameters. What we were using? Int x, int y, and we were passing also a and b or x and y. But now we are passing address and we are storing it in the pointers. We are passing address from main function, and in the function definition, those addresses are getting stored in pointer variables. They are getting initialized to pointers. And using star pt, so now ptr1, where does it point to? Ptr1 points to x. Ptr1, since it holds the address of x, it points to x, and ptr2 will point to y. So when I write star ptr1 is equal to 20, what will happen? Which value will get updated? The value of x will get updated because ptr1 points to x. So star ptr1 will update the value in the memory, and that same location is for x also. So x will become 20. Okay. So even in the main now, x is 20. Why? Because we are accessing address. We are accessing memory location, which is the same for x, and ptr also points to that same location. So any change made to the value using ptr or any change made to the value using the variable itself will reflect in the memory and will reflect in x and star ptr also. So now x is equal to 20 because star ptr I've updated, and here star ptr2 is 10, so y will also get updated to 10. So this will become 20 and this will become 10. See, what was the difference in call by value? Whatever we did inside the function did not reflect outside the function, isn't it? Whatever we did in our function, any updation, that did not reflect to the parameters which we passed. We passed x and y, but they're different from this x and y. So whatever we do manipulation on x and y inside the function, that is unique and local to the function, but that will not get reflected to x and y outside the function. So there is level of security. But in call by reference, since we are passing address, at the address which is unique, which is related to both x and the pointer pointing to x, since the address we are updating, we are doing some updation at the address. So even outside the function, it is getting reflected. I hope you understood the difference between call by value and call by reference. If not, you can rewind the video and hear it again. So as I said, ptr1 and ptr2 will also be stored in memory. So what will be the value of ptr1? 1000. What will be the value of ptr2? The address of y, that is 2000. And using ptr1 and ptr2, I can access x and y respectively, and the value will reflect inside and outside the function both. So ptr1 points to x, ptr2 points to y. And now, if I go to print x and y outside the function, that is in my main function, then what will get printed? Will it be 10 and 20, or will it be 20 and 10? See here, when I updated, even in the actual x and y, the updation took place. Isn't it? 10 became 20 over here and 20 became 10 over here. So when I print x and y from main, the output will be 20 and 10. I hope you understood this. We will see it using a program now. We have performed the famous program of swapping without using functions. Now we will use with functions and with pointers. So first is our normal call by value. In the main function, I have x and y as 5 and 6. I can print x and y before swapping. Then I pass x and y to a function swap, which is a user-defined function. So the user has to define it. It is not predefined and available that you have to just call it. You have to define it if you are using the user-defined function. So I'm passing x and y to swap. Control will jump to the header. And then I'm using temp variable, temp equal to x equal to y equal to temp. The general standard strategy to swap numbers. And after swapping, I can print x and y, but only from within the function. Because in call by value, whatever you do inside the function is only local and accessible from within the function. So now x is interchanged with y, and you can print it here only. So before swapping is in your main function, and after swapping is in your swap function. So when I execute this program, see here, before swapping, this is getting printed from main function, which we have hard-coded the values. And within the user-defined function, we have swapped, and from within the function itself, we can access the swapped values of x and y. But this x and y and this x and y are different. So actually, in memory, what happens? This x and y remains as 5 and 6 only, but the x and y of the function is only updated. Okay. See here, I'll show you. In your main function, you have x and y. And these are the values before swapping. They have 10 and 20, suppose. And in your swap function, which is a function which is outside the main function, what happens? You are interchanging x and y. And this x and y is nothing but the x and y of swap function. It is not the x and y of main function. So here you are interchanging the values. And so only from here you will be able to print after swapping. But actually, x and y, which we had considered for swapping, this x and y of main we had passed as parameters, but they are not swapped actually. They already have the original values 10 and 20. What is swapped is the x and y of the swap function. I hope you're getting me. So this is the disadvantage of call by value. What we think is not what happens. X and y of main remains the original parameters, but after swapping is by the function which is having the local x and y. So this can be avoided by call by reference. Means what? Using pointers, you can refer to the same memory location, and hence the actual parameters value will get updated. I hope you have understood why pointers are so important. So before swapping, x and y is 5 and 6. I'm calling the swap function, and then after swapping, I can print in the main function because the actual in the memory, the values are updated. So it is reflected throughout your program, and you can access x and y in your main also. So this x and y, which you have accessed here, passed to the function, and this x and y, all is the same, and they are actually swapped in memory also. So you can swap the variables without physically moving them. Now there is a change in your function definition. In call by value, what you are passing, x and y. In call by reference, you're passing address of x and y, which is getting stored in the pointers p1, p2. Then you can interchange their values. And here, when you print after swapping within your swap function, whenever you write after swapping within your swap function, it will give you the exchanged values. And after swapping in your main function also, since it reflects throughout the program, the values will get swapped. Let us execute and see what is the output. See, before swapping in your main is 5 and 6. You have swapped by calling the function, and after swapping, values are interchanged as 6 and 5. So this is the advantage of call by reference, that you are referring to the same memory location. Though it has an advantage, the disadvantage in some cases may be what? Where you want to provide security to your variables. But since they are accessed but to the same memory location is exposed, so the values may get updated. So there is no level of security here. But in call by value, there was security. So each method of calling, this is known as calling, it has its own merits and demerits. I hope you understood this. Now next topics are void pointer. These are some types of pointer which are useful in programming. We will study void pointer, null pointer, and dangling pointer. So void pointer is a pointer whose data type is void. Now, see, if you write int a equal to some value 10, and if you write int star p is equal to address of a, then we are saying like data type of a is int, data type of p is also int. But actually, how will the computer differentiate whether it is a pointer? So for this purpose, what is written is, in the computer understands that the data type of p is not integer, but it is int star. For the computer to differentiate between simple variable and pointer variable, it considers that the data type of p is int star and not simply int. But when we say it theoretically, the data type of both is integer only. This is also a noteworthy difference. So whenever you want to return a pointer, what is the data type? It is int star, if the pointer points to an integer. So here, what is the return type or the type of the pointer? It is void star. Now void is nothing but valueless, or it doesn't have any worth. But here void, where we have seen in function returns, if the function does not return anything, then the return type of the function is void. Similarly, initially the data type of pointer is what? Void over here, and it may point to some location, but it does not have a specific type, isn't it? Now we do not have void variables. No, we do not have void a. So what happens? We cannot assign anything here if the data type of the variable is void, but the data type of the pointer is void. This is accessible and available. So here what will happen? Void refers to the type of the pointer. Basically, the type of data that it points to can be anything. See, this is an important point. The data type of the pointer, if it is void, it can point to any other data type. Means what? The void pointers can point to any data type like integer. It can either point to float, or it can also point to char. This is the speciality of void pointer. Now the code that can be suitable for different data types, this is the concept of generic programming. Means you can generalize the lines of code to deal with different data types. This is known as generic programming, which is an important concept in C++ usually, but it has some implications in C language also. So the pointer, which is void, can point to different data types. So it is generic pointer also, you can call it, or void pointer. GENERIC, generic. Now any pointer is convertible to void pointer, and hence it can point to any value. Now important points to note is, you cannot directly dereference a void pointer. Dereferencing means what? Accessing the value to which the pointer points. Void pointer can point to different data types, but unless you do typecasting, you cannot dereference the void operator. Means you cannot access the value to which the void pointer points unless and until you typecast it. So we'll see this. And one more important thing is pointer arithmetic, like the increment, decrement, or assignment to the star PTR. That is not possible with void pointer because the compiler cannot deal with it because it has some lack of the concrete value. It does not have a specific type, right? It is a void pointer, and you are typecasting it in order to access some value. So it does not have a concrete type, and on void type, you cannot perform arithmetic operations. So in your main function, you have int a equal to 10. Void star ptr is equal to ampersand of a, means ptr points to a. And now you have to typecast it in order to access the value 10. See the example at the right. What I've done, same thing, initialize the pointer to a, address of a, and then I'm simply writing star ptr. But this is void pointer. So you cannot access the value directly 10 here. It will give you error. So what you have to do, you have to do typecasting. See, for typecasting for variables, how have we done? Suppose we have a float a equal to 3.14. And if we want to typecast this float variable to integer, then how we do it? We have to write within round brackets int, and then we can print the value of a. So this will convert 3.14 to the integral part, that is 3, and that will be the value that will get printed here. You can also write b is equal to int of a, where the data type of b is integer. Okay, since you are storing the integer part of a in b, which is also an integer, this is allowed. So for this is typecasting for variables. But what about typecasting for the pointers? This is possible by using this extra syntax, which I've highlighted. So whenever you want to access any value using pointer, you have to write star ptr, and you can print it. If you want to typecast, then what you have to do? Between star and ptr, you have to do the typecasting. You must write star, and to what you want to typecast. Suppose you want to access an integer value, then you have to typecast it to int. And not only int you have to write, since I've already told you, compile how it identifies that it is a pointer or a variable. The data type of pointer is int star or float star, and data type of simple variables are int float. So the typecasting must be done to int star since it is a pointer variable. And then you must write the name of the pointer variable. So this is typecasting for pointers. And then you can access by this whole statement. This whole statement will give you the value of a. Okay. You can execute this at home and check it out. Next is null pointer. This is a pointer which is initialized to the value null. See, sometimes we declare the pointers like int star ptr, and then maybe in large programs we forget to initialize it to some address, or we forget to make it to point to some variable, and directly we try to access the value of ptr. This is a point of caution which I've explained just a few minutes ago. This is not correct what to do. It is invalid. So what must be done? It must be initialized to null for security, means so that your code doesn't give you an error. So if it is initialized to null, means it is a valid declaration and initialization. And now if you do star ptr, it will give you the value null, or it will give you the value 0, because null is indicated by the arithmetic value 0. So here if you try to print the value of ptr, which is an address, it will give you, if you try to access the value of ptr, it will give you null. So let us see this in a program first. So here I have a variable a holding value 12 and a pointer to an integer ptr which is assigned the address of a. Okay, this is acceptable. But here I'm not initializing, I'm simply declaring. And then if I want to access the value of ptr, it will give me error. So I have to initialize it to null. Now this is what initialization, valid initialization. And now if I try to access the value of null, the value of pointer can be printed using address of, I mean the address format specifier, and you can write here ptr. See here, what is the value of ptr? It is initialized to 00000000. This is nothing but null in compiler. So 0000 is nothing but the base address, that is the starting address of the stack segment. Now we have seen in our previous programs we have different sections of memory like heap, stack, static, or global, or code. So stack is used for the local variables or the functions, whatever variables are used in the functions that will be allocated memory in stack. Then for the static or global variables, we have the global segment of memory. And for the code or the instructions, the memory allocated is in the code segment. So in stack, you are having the memory allocation for pointers as well, because they are the local variables of main function or any other function also. So the base address of stack, that is starting addresses of stack, is 00. So that is the value of ptr. That is the actual value of null. So null is a defined value. Now if I want to access the, if I write asterisk ptr, and since it is integer, I use %d, let's see what happens. So it does not give any output. Why? Because ptr is not pointing to any location. It is just initialized to null so that you don't make any error in your program. So when you write %ptr, it will not give output, but ptr ka value is an address. What is that address? 00. This is null pointer. And value of ptr is, we have seen just now, it is 000, 8 times. And what will be the size of null? We can print that also. And this is undefined. So size of null, let us see what is the output. Size of null is 4. Why? Because ptr is of integer type and int occupies 4. Let me change it to char and let's see what happens. It is still giving 4, means size of null itself is 4. Okay, it does not depend on the int or char. Size of null itself is 4 bytes. That is why we have 4 times here 0 zeros. When we were getting the output, 4 pairs of zeros we have. So size of null is 4. Now, if we try to increment the value. See, PTR is currently to initialize to 0, 0. If I write PTR plus plus, and this 0, 0 is nothing but in hexadecimal. This is not binary, this is not decimal, this is hexadecimal because addresses in the memory are in hexadecimal format. So 0 is the first hexadecimal number. Now since this is of integer data type, whenever I do plus plus, the pointer will jump by 4 bytes. Okay, it's an important thing to note. Since it is integer type, whenever I do PTR plus plus, whatever is the current value, that is 0, 0, it will jump by 4. That is, it will become 0, 4. Okay. Now when I try to print the value of PTR, it should give this one. See here, the value of PTR after updating is 0, 4. So it jumps by 4 bytes. Now again, if I do PTR plus plus, or I can write PTR plus equal to 2, means PTR plus plus, PTR plus plus. PTR plus plus does increment by 1. If I do plus equal to 2 means increment by 2. And the value is incremented in PTR. So 2 jumps, that is plus 4 plus 4. That is, it will give me 0, 8. Now, in hexadecimal, see here, this is the conversion table for decimal, binary, and hexadecimal. So what I have written, what is written here? For 0, it is same in hexadecimal and binary. Then for 1 till 9, for 1 to 9, it is same in hex and decimal. But when decimal is 10, then hexadecimal equivalent is A, and it is capital A. Here, by mistake, they've written small a. For 11, it is B. 12, it is C. Since you've studied number systems, you know it. Then till 15, F. Then when it comes 16 in decimal, you have to start from 10. You had stopped at 9, then A, B, C, D, E, F. Then you have to start from 10. Go on 11, 12, up to 19. Then when you come across 20 in hexadecimal, it is nothing but 1A. Okay, then 1B, 1C, till 1F. Then where you had stopped, 19, you have to continue from 20. Now this pattern is followed, and there's no necessity to remember this pattern. Why? Because you know how to convert from decimal to hexadecimal, right? Whenever you have to convert from decimal to hexadecimal, you have to divide the decimal number by 16. If from decimal to binary, divide decimal number by 2. If from decimal to octal, divide decimal number by 8. So that's what I'm going to show you here. See here, when you do 26 is in decimal, this needs to be converted to hexadecimal. So how will I do? I'll divide 26 by 16. So 16 ones are 16. Remainder is what? 10. But 10 in hex is what? A. So 1 is remaining to be divided. 16 zeros are 1. Remainder is 1. And you have to write it from bottom to top. Yeah, bottom to top. The arrow is written the wrong way. It is from bottom to top. So the answer of this is what? It will be 1A. That is 1 and actually 10. But in hex it is 1A. Okay, this is a little wrong. So when I do PTR plus 2, it is giving me 8. Now if I do jump by 3 times, so 4 3s are 12. So it will give me 12. But 12 in hex is what? 12 in hex is C. Okay, so it should give me C. Let us check. See here, it is giving C. Okay. Because C is 12, but 12 cannot be represented like that indirectly in hex. It is C. And here, similarly, if you do jump by 4 times, then 4 12s are, 4 4s are 16. So 16 in hex is what? it is 1a. That is 10. 16 in hex is a, only a, that is 10 directly. Okay, till 15, 10 is a, 11 is b, 12 is c, then 15 is f, and 16 in hex is 10. Okay, it is 10. So that is getting displayed at output. Similarly, if I jump another time, then it will go to 4 into 5, that is 20. And 20 in hex is what? 14. So it is giving me 14. So this proves that addresses are in hex in the memory, and each time you jump, it goes by 4 bytes. Why? Because integer, so it occupies 4. So if this was character, let us check what happens. If I jump by 1, here I'm jump. Next is after 0 comes 1 byte, right? So after 0, 1, you will jump by only 1, since it is character. If I do plus equal to 2, then it should give the output. If I jump by 15 times, then should it give f? Let's see. Yes, it is giving. Okay. So depending on the type of your null pointer, when you increment those many times, it will jump. For integer, then it will jump by 4 for each increment. Similarly for float, because float also occupies 4 bytes in memory. This was null pointer. And kindly note that uninitialized pointer, that is whenever you write asterisk ptr, means when you declare a pointer of suppose type int, then this is uninitialized. But this and your null pointer are different. Null is a defined value, it is initialized, but only writing int star ptr is declaration, it is uninitialized. There's a difference between null and void pointer is generic pointer. Void is a type, but null is nothing but a value. Okay, this is also a difference. Then we have wild pointer. Wild pointer means the pointer which is not initialized. That is your declaration. Okay. And then when we write int x equal to 10, this is a simple variable, and now we can store or initialize it to some address. And now it is not wild. This is proper pointer, but this is a only declared pointer. So at this point, it is wild. At this point, it is not wild. You can read the theory at home. And let us see if here, now it is currently null. Now if I write ptr is equal to ampersand a, and now I try to print the value of ptr using star. See here the value of ptr is null, but here to the value of, if I write only ptr, what will be the value of ptr? Address of a. And if I write asterisk ptr, it will be the value of a. So let me give percent, I mean backslash n here. So null is 0, and after that I'm initializing it to some other value which is allowed. Okay, at declaration you can use null, and afterwards you can initialize it to whichever value you want. If you use %d, then it will write 0 only once. If you use %p, since null is an address, it will give you 4 pairs of zeros. So I hope you understood these concepts. The remaining concepts, that are memory allocation using malloc, calloc, realloc, and other concepts of function pointers, we can discuss in the next sessions. So I hope you will practice all this at home on your own, because just hearing my lectures without practicing it on your own will not suffice and it will not help you. So I hope you'll practice all of this. And if you have any doubt, you can ask me when we meet live, that is tomorrow on the 12th. And thank you for watching this video.